There are people for whom 55 degrees is just a Tuesday. You're dead in an hour. They go to work. Today, we're finding out why and what exactly is wrong with your body. Also, a lot is wrong. But before we get to the wrong things, a quick note about what heat actually does to a body. Your core temperature is 37 degrees. That's not a preference. That's a hard requirement. Enzymes work at that temperature. Proteins in your cells fold in a specific way. Your brain runs on a precise chemical balance that depends on everything staying where it is. Add heat, everything starts to drift. Your body knows this. It panics immediately, sends blood to the skin, activates every sweat gland it has, speeds up the heart, does everything it can to keep that core number from climbing. The problem is that this costs energy, it costs water, it costs electrolytes, and at some point, the system runs out. At 50 degrees, in direct sun, no shade, no water, the average unacclimatized adult has about an hour. Depends on how hydrated they started. Doesn't depend very much on willpower. Sorry. Number 7. Superhumans of the Sahara. So, you're in the middle of the Sahara. Noon. 50 degrees. Shade? Great question. There is no shade. The sand reflects heat upward. The sky pushes heat downward. The air sits completely still because even the wind has decided this isn't worth it today. Your body launches the panic protocol. Sweat glands, full blast, heart rate spikes. Blood rushes to the skin trying to dump heat. The first 20 minutes feel survivable. You're sweating, you're uncomfortable, but you're functional. 20 minutes in, your core temperature starts climbing anyway. 30 minutes in, you're making decisions you'll regret, like sitting down. The sand is 60 degrees. You stand back up immediately. An hour in, heat stroke, brain swells, coordination goes. You stop sweating. Feels like a relief. Finally. But no, that's your body giving up. Sweat is the last line of defense. When it stops, the temperature climbs fast. The proteins in your brain cells start to lose their shape. Things stop working in the order they need to work. You're dead. About an hour. Not bad for someone whose last adaptation to nature was an opposable thumb. The Tuareg, meanwhile, watch this process with mild interest. They've lived in the Sahara for 2,000 years. Not survived it, lived in it, traded across it, raised families in it, built an entire culture inside what you experienced as hostile for 45 minutes. Their metabolism slows down in the heat on its own. The body reduces its internal heat production. Because why add to what's already there? It's not a trick they learned. It's built in, automatic. When the temperature climbs, the furnace turns down. Their sweat glands lose less fluid for the same cooling effect. More efficient use of the water they have. Smaller sweat volume, same temperature drop. And their traditional clothing, full body wraps, holds a thin layer of cooler air against the skin and blocks solar radiation. The gap between fabric and skin insulates in both directions. Keeps the sun out, keeps the cool in. Wait, seriously? They're cooler in those wraps than you are in shorts. Sit down and think about your life. But drink some water first, and find shade before you sit. Number 6. Superhumans of the Persian Gulf. Bahrain. August, 35 degrees. Humidity, 95%. You step outside and the air feels like a warm, wet towel that someone wrapped around your face without asking. Your cooling system works through sweat evaporation. In 95% humidity, the air is already saturated. Your sweat has nowhere to evaporate to. It just sits there, on your skin, doing nothing. You're producing all the sweat, getting none of the cooling. You're just wet and hot at the same time, and that's not as good as it sounds. 20 minutes in, you feel worse than you would in dry 50-degree heat, because dry heat lets you cool. This doesn't. 40 minutes, heat exhaustion. An hour, serious problems. 2 hours. You're an interesting case in someone's medical journal. The title will be polite. The prognosis less so. The pearl divers of Bahrain worked these waters for generations. Open boats, no air conditioning, diving repeatedly into warm, shallow water and surfacing into humid air all day in August. Their hearts pump blood more efficiently under heat stress. The cardiovascular system adapted to sustained effort in high temperature, high humidity conditions. Less strain per beat, more output per liter of blood. And their cells produce heat shock proteins, tiny molecular defenders that act as chaperones for other proteins inside the cell. When temperature rises and proteins start to misfold, the heat shock proteins catch them, stabilize them, Keep the cell functional when it should be breaking down. Wait, cells can cook? Yes, yours can. At a certain temperature, proteins inside your cells lose their three-dimensional shape. They unfold. An unfolded protein doesn't work. This is, medically speaking, a problem. Theirs can't. Or at least, much less so. The heat shock protein system is better developed. More proteins, faster activation. You have some of those proteins too, just significantly fewer. Maybe you should have gone outside more, but it's too late to talk about that now. Let's keep moving. Number 5. Superhumans of the Australian Desert. Welcome to Western Australia. Red earth, scorching rock. The kind of silence that feels less like peace and more like warning. Nearest water, 80 kilometers away. You don't know that yet. Right now, you're wondering why you agreed to come here. You're also wondering if the map you brought is accurate or decorative. It's decorative, 49 degrees. The iron ground reflects heat from below. The rock surface is 60-65 degrees. Sun hammers from above. You're in the middle, like a sandwich. But instead of bread, 2 surfaces of burning hell, and instead of filling, you. Your aquaporin channels, proteins that move water between cells, weren't built for this. Cells dehydrate from the inside. The pressure balance shifts. Cells start to shrink. Your brain sends an alarm, then asks for water. Then sends the alarm again, louder, without stopping, at maximum volume. You can't think clearly. Your reaction time drops. You make another bad decision. You sit down again. The ground is 60 degrees. You stand back up immediately. You're dead. Maybe 2 hours. We're being generous. The circumstances are already pretty bad. No need to pile on. The Pintubi people have lived in this desert for at least 30,000 years, not as guests, as the people who belong there. Their sweat glands activate at a lower skin temperature. They start cooling before you've even noticed it's warm. The system doesn't wait for an emergency. It starts early, works steadily, and stays ahead of the problem instead of chasing it. They read the landscape in a way that has no direct translation. They see dry rock and find hidden underground water. They recognize signs in the vegetation, in the soil, that indicate water exists somewhere below. A skill built across thousands of generations of living and dying by whether you could find it. Their aquaporin channels retain water more efficiently at the cellular level. Less loss per hour. Longer operational window in the same conditions. You need a bottle. They need the desert. Feel the difference. Number 4. Superhumans of the Danakil. Ethiopia. The Danakil Depression. The hottest inhabited place on Earth. Wait, the hottest inhabited place. Meaning people live there, voluntarily, as a lifestyle choice. Average annual temperature, over 34 degrees. Not in summer, on average. Peaks hit 55. The ground is partly volcanic and vents heat from below because apparently the heat from above wasn't enough. You're being attacked from above, below, and all sides simultaneously. Your blood sodium levels drop as you sweat. Hyponatremia. The concentration in your bloodstream falls below what your nervous system needs to function. At first, you feel a little drunk, lightheaded, slightly disconnected. Everything is interesting and slow. Sounds fine. Then come the seizures. That's a completely different conversation, one we're not having today. The Afar don't just live here. They mine salt, physically, with pickaxes, in 55-degree heat. And then they go home. Then come back tomorrow. Their metabolism produces less internal waste heat. Sweat glands retain electrolytes. Salt stays in the blood instead of pouring out with the sweat. Cardiovascular system built for long operation without emergency shutdown. They get paid for this work. Not a lot, but they get paid. You would ask for a bonus for working at 25 degrees, in an office, with air conditioning. And honestly, you might get it. Number 3. Superhumans of Rajasthan. Rajasthan. May, 48 degrees. There's wind. That sounds like good news. It isn't. The wind here is hot. 48 degrees moving is just 48 degrees with more range. It dries out your eyes. It pulls moisture from your skin faster. It gives you the sensation of ventilation without any of the actual cooling. Creative. Completely pointless. 40 minutes of physical work. Heat exhaustion. Heat causes muscle fibers to break down, rhabdomyolysis, and the fragments enter the bloodstream. Your kidneys try to filter them out. They're not built for this volume. Cramps in the hands, then the legs. The harvest has stopped being your primary concern. Agricultural families in Rajasthan have worked these fields for generations. Their heat shock proteins run at a permanently higher baseline. The system doesn't wait for heat stress to activate. It's already running. The body is always on low-level standby for temperature emergencies. Recovery from heat stress, faster. The system that detects damage, repairs it, and resets. It's better calibrated, more practiced. Most importantly, their adaptation wasn't earned through training. It was built before birth, written into the genome by generations of selection. The people who survived this work and whose children survived it passed something down, not a technique, a biology. Your adaptation, 2 weeks at a hotel in Turkey, air conditioning, buffet breakfast, a pool that was slightly too warm, close. But no. Number 2, Superhumans of the Sahel. The Sahel, the strip between the Sahara and the tropics, a landscape that can't decide what it is and compensates by being difficult in multiple ways at once. The heat here is unstable. It doesn't sit at one level and stay there. It jumps. 42 in the morning, 47 by noon. A wind shift, and it drops briefly, then climbs again. Your thermoregulatory system works well when heat is steady. It was designed, more or less, to handle a stable input and maintain a stable output. Variable input is harder. The system is always recalibrating, always catching up. You're chasing the temperature instead of anticipating it, like putting out a fire after the house has already burned down. Under sustained physical effort, your core temperature climbs faster than it should. It's doing its best. It's just not enough. West African endurance runners, from regions with long heat exposure histories, have bodies that look like they were designed with specific engineering goals in mind. Longer limbs relative to body mass, more surface area for heat dissipation per kilogram. Sweat distributes more evenly across the skin. Maximum evaporation, no waste. Core temperature under maximum effort stays measurably lower than athletes from cold climates, even when external conditions are completely identical. Same track, same temperature, same effort level, different result. Come on, seriously? Researchers write papers about this. The graphs are frankly embarrassing for everyone who isn't from West Africa. These runners win marathons. It doesn't look like effort. It looks like a different relationship with the environment. You wiped your sweat, went to get another bottle of water, and came back to watch the finish line. That's also adaptation. Just a different kind. A kind that involves significantly more plastic bottles. Number 1, the perfect heat human. All right. We've been through deserts, bays, depressions, and volcanic fields. We've established that your body is doing its best in conditions it wasn't built for, while other bodies, shaped by thousands of years of exactly the wrong environment, operate comfortably in things that are actively trying to kill you. Now, the best part. What if you took the best from everyone? The Tuareg metabolic slowdown. Body generates less internal heat when it's already hot outside. The furnace turns down automatically. No panic, no waste, just a quiet reduction in self-generated thermal load. The Pintubi early sweat gland activation. Cooling starts before the emergency, not during it. The system is proactive. It reads the temperature direction and responds to the trend, not the crisis. The AFAR sodium retention. Electrolytes stay in the blood even when the entire body is running as one continuous sweat mechanism. The nervous system keeps its signal. The heart keeps its rhythm. The kidneys are not called upon to do the impossible. The Sahel runner body geometry, limbs as radiators, minimum core mass relative to surface area, sweat distribution mapped evenly across every available centimeter of skin. The pearl diver heat shock proteins, cells protected even when core temperature climbs past the point where regular cells start to malfunction. The molecular repair crew is large, fast, and already at the worksite. The Rajasthan cardiovascular stability, a heart that doesn't panic when the conditions get bad, that just quietly, efficiently continues to do its job. No escalation, no emergency mode, just operation. Put that together in one body. You get a person who walks through the Danakil depression in July and finds it brisk, works a full shift at the salt flat and calls it a light Tuesday, runs a marathon in Bahrain in August and comes home, slightly sweaty, makes tea, sits down, wonders what to have for dinner. That person exists, by the way, not as one individual, but as a combination of traits spread across different populations, refined by different environments. The pieces are real. We just haven't assembled them. One catch. This person sweats absolutely all the time. At work, at home, in winter, on a first date, during a job interview where the air conditioning is working perfectly, during video calls, in their sleep, at room temperature. Evolution gave them the most efficient cooling system on the planet, and it runs constantly, regardless of actual need, regardless of social context or professional setting or romantic aspiration. Every superpower has a price. How are you doing, by the way? I'm fine, just a little sweaty. Yeah, is that normal? For you? Completely. See you next time. Drink water, and watch this one next.